before we begin, I do need a little bit of help. Hopefully you're all familiar with Slido. So I'm going to ask you to go here. There's just 3 questions, and I will remind you that I stand between you, drinks, and snacks. And we're not leaving here until I see some pretty good answers on this board. So please scan or type in a number, and I just want to know what resources you would need as a requirement, as mandatory, before you ship an application to production in Kubernetes. Yeah, so the Kubernetes resource model. The first one being a deployment. Yeah, so anything that you can type an API version and kind for, I would like to see them on this board. And I'll take abstractions too. Observability stack is fine. We can go into that in more detail. Yeah, pod's kind of needed, right? I'll just give you another minute. Well, the bar is not very high for production, is it? Curse words, definitely. I'm Scottish, I do swear, so I hope you're all right with that. Okay, so we've got some good answers there. Obviously, we need a deployment, we need a service. We've got a little bit of RBAC sprinkled in there. Someone's mentioned some service mesh, networking policies, load balancers, awesome, Argo rollouts, observability stacks, and so forth. Yeah, so the point here is that, well, we try and pretend that you can just write a deployment YAML in 20 lines and you get something running, and you kind of would. Actually, the deployment landscape and the complexity of deploying to Kubernetes, especially in production, is very vast. And this is not slowing down. You know, we have a lot of operators and custom resources that we need to create next to all of these more standard core APIs as well. So now, let's understand the tools that you're using. So how do you deploy to Kubernetes at the moment? Option 12, thanks. All right, so pretty vanilla then. Everyone's just writing straight up YAML using Helm, I'm assuming, for third-party dependencies. Perhaps you've written general purpose charts for your own use. That's perfectly all right. 45% of you hate yourselves and use Terraform. I'm going to touch on Terraform a little bit in the tooling. It's getting better, but there are definitely some huge challenges there. Customize, I would like to see a bit higher, just because it is now baked into kubectl, while it is a little bit further back in the version-wise. You still get some pretty strong, powerful things out of it, so that's cool. And then JSON it, yeah, I don't see much of that in the wild anymore. But we have no Pulumi, no Carvel, no Q, no CDKates, no Capitan, and no KPT, which is pretty standard. I never see anybody using these tools, but they are some of the cooler tools on this list. Last question, rate your experience of happiness of deploying to Kubernetes. I did consider letting you type in words for this, but I decided better judgment not to. All right, people are lying to me already. There we go. Oh, it's quite a split. You can only vote once, right? These aren't just, yeah, good. Yeah, so more angry faces, which is good, some happy faces and rockets, which I don't believe you, and then the poo emoji I did expect to do a bit higher. Okay, so my name is David. My funny accent means that I'm Scottish. I'm a Kubernetes educator and consultant. I work with teams to help them build Kubernetes platforms to enable their developers to deploy and ship faster. I put masochist on this slide just because I knew that someone was going to review this and have no context, and plus people will read this online and have absolutely no context either. I'm not really a masochist, but I do something pretty stupid that I want to share with you. on my YouTube channel, which is the Raw Code Academy. Now, out of curiosity, anyone familiar with that? Seen it before? All right, that should be at least another 50 or 60 subscribers in. Thank you all. So, this is a very small clip. It's not going to take long, but I do have a show on my channel called Clustered. It's the single best and worst idea I've ever had. It started off where I would spin up 2 bare metal Kubernetes clusters, give them to random people on the internet and tell them to break it. I would then go onto my live stream and try to fix the cluster and get it working again. I enjoy fixing clusters live on a stream. It keeps me humble, but I also enjoy watching other people try this too. And this was a team episode with people from Red Hat and people from Talos. So they're very smart people that have been in the Kubernetes space for a long time and even work on their own Linux-based operating system to help make Kubernetes easier. And to give you a taste of it, here is a very short clip. Now, before I hit play, let's just get the context here. Now, I've made this clip really short, so that's why I'm doing the context. But they've exported their kube config, and they've tried to run kube control get nodes, and they get permission denied. Right? We all know how to fix that, yeah? You go down a couple more lines, they try to chmod the kube control binary, and oh, the executable bit on the chmod is gone. Who knows how to fix this? That's all right. With Kubernetes, right, you don't learn this stuff until you have to learn it through trial and tribulations. But you throw some Linux experts onto it and you find some cool ways. You can actually execute any system call via the dynamic linker, so the ld.linux.so file. Really cool hack. But this hack was actually a little bit more sneaky because they then tried to run ls on bin. And if you understand how colors work on ls, so they moved the executable bit from kube control, kube admin, OC, I don't even know why they put that crap on my thing, SCP, change attributes, chmod, and so forth. So they really went to town, and this was in the first 30 seconds of this cluster. So it was good fun. All right, so yeah, I like doing stuff like this. Check it out if you want to learn more about Kubernetes and Cloud Native on my channel. So what does a Kubernetes deployment look like in the real world? And again, I'm focusing on production here, not development, local staging, and so forth. Well, you probably need most of these resources. We didn't see them all listed, right? But we have a deployment, we have a service, we have our config map and secrets, we have the horizontal pod autoscaler, the pod disruption budget, pod monitors, networking policies, and so forth. At the smallest amount of YAML I could write, we got it at about 120 lines, which looks like this. That's as good as it's going to get, but it's not actually that important. And this is not even comprehensive about what I would want to deploy something to production. We need much more, right? The chances are we need to create and provision namespaces. We definitely need service accounts because we're not going to do default injection. We've got roles and role bindings. Our applications usually have state. If there's no state, they're probably not making any money. So you need databases, you need queues, you need caches. Something I never see in the wild, and it makes me really sad, but people aren't applying setcomp profiles to their applications. Why not? All right, but this is more stuff that we need to add to our applications. And then we've got limit ranges, ingresses, and so forth. And even at this is still not comprehensive, right? There are a lot of things that we need to do to deploy to Kubernetes. So is this a problem? And I'm not going to answer this question. I'm going to let my good friend Robin Williams answer this question.
I want to do this one time. Fuck no! 18 fucking turns!
Oh, I'll just watch it twice. That's all right. So, I mean, you don't need context for that joke. He was talking about golf. But we don't deploy monolithic applications to Kubernetes. Well, I mean, you could, right? But you're probably not getting many of the tangible benefits for deploying a monolithic Kubernetes cluster, especially with the operational complexity of running a Kubernetes cluster. So we have to deploy our microservices to Kubernetes. So we have to take all of these resources, and we copy and paste the YAML, and then we do it again and again and again. And then if you want to make a change in one application or one service, but it's a best practice, and we want to apply that across all of our applications, we have to start looking at more tooling, because straight up YAML isn't going to cut it anymore. Which is why, when we ask the tools, we're seeing Helm so high up there, because Helm does provide a nice way of handling some of this complexity. But it's not without its own challenges too. So what do we want and what do we need from our tooling to be able to tame this complexity of deploying to Kubernetes. Well, these are the things that I think that we need. We don't want it to repeat ourselves, right? Dry, something that we do with our code is that if we can find a way to make something reusable, then we should. I've also added shareable here because it might be that we want to expose these things to other people, other teams, other organizations, other divisions, even publicly by providing best practices and libraries for others to consume. And while we want opinionated libraries or configurations for deploying to Kubernetes, they have to be composable. You have to be able to opt in to the features that you're ready to do. Maybe you're not ready to jump into the service mesh and do loads of networking policies and do seccomp profiles, but it doesn't mean that you're not going to want to come back to that at some point in the future. Now, we also want our working with our YAML or our Kubernetes resources, we want documentation. Anyone know how to get the documentation or understand the spec of a custom resource definition without going to the code? It's my favorite trick, and I don't know why people don't know this command exists, but kubectl explain is the best command in the world. And just because there were a few blank looks there, I'm actually just going to show you it. So let's have a quick peek. So this works on any Kubernetes cluster. Anyone got a favorite resource? No? Ingress. All right, now we can say that we want to look at the spec. And now we see all of the fields and the documentation. We can see that we need a default backend, or we can have a default backend, ingress class names, rules, and so forth. This works for any degree of nesting, so you can then continue to add and work your way down the tree. Fantastic little trick. Anyway, documentation is not great. When you're writing YAML and you want to be able to understand what the spec of a resource looks like, the documentation, the LSPs, they're really not where they need to be to make this easier and provide a strong, enjoyable experience. And testable. Anyone here testing their Kubernetes YAML? No, okay. There are tools for it, but we're just not doing it either. So we're going to play a game of can I, should I? Everyone's heard of this game, right? So if we wanted to dry with YAML, what do we go for? Anyone familiar with YAML anchors? Right, they look like this. You can name certain parts within a YAML document, reference them in other parts. It does actually allow us to clean up some of the more annoying duplicates. I don't know, I'm sure there's a word there I'm missing. Within our YAML, especially in a deployment spec where we have label selectors and so forth. But it only works within a single YAML document. Even if you have a list with multiples, you can't like have a nice bit of shared stuff at the top and reference it all the way down. So it's not really where it needs to be for us to be able to do that. Plus, it just doesn't look that nice, and it's difficult to understand. This is why we then have customize. This provides multiple ways for us not to repeat ourselves using overlays, patches, remote includes, and even they've got a small function library that allows you to do some stuff as well. However, customize is a good first step, and if you are just shipping Kubernetes YAML, go for it, right? Enjoy taking some of those benefits. But we just have to remember that there are better tools with a better, consistent developer experience. Customize solves some challenges, but it's not really solving all of the problems that we have with working with YAML. Now, can I, should I? Yes, I mean, do use customize, but hopefully by the end of this talk, you'll see that there are better ways as well. Now, if we want to make things shareable, we use Helm. And I don't want to say, no, that's a lie. I do want to say bad things about Helm. But Helm is great, right? I love that we can go out and get any Helm chart for any third-party piece of software and deploy it. But Helm is not without many, many, many challenges. Now, I'm not a fan of Go's template language, which is what we're looking at here. I think working with YAML is very painful because we have to worry about white spaces, which is why we have these little dashes next to the braces. If you get them wrong, the indentation is all wrong, and then your YAML doesn't validate, conform, or even apply. We then have these magical context variables with the dots, so you're throwing them around. For people that have written YAML and you throw this in front of them, right? While it was true 5 years ago that everyone working with Kubernetes probably was a Go developer, that's not true anymore, and now we're forcing this upon them. We then have the ability to include files, But then we have to make sure we indent them correctly. They also use the magic context dot. We can then do print blank lines, which you see in many Helm charts. And I don't know why this exists, but it's painful. So it's just not pleasant for people to work with. And the only way to see what the output is to run a Helm template or run a Helm install. And then there's even more challenges with Helm, where you've got this CRD conundrum. Do we have Helm install the CRDs? Do we install them ourselves? And how do they get managed from that point forward? So I'm not going to say anything bad about Helm, but I'm also not going to say too much that's good. Now, the main problem with Helm is the values file. Now, this is our point of customization. This is where we tweak the chart to make it do the things that we want it to do. The problem is there's no strongly opinionated Helm charts out there. I mean, I can't just cast a wide net and say there are none, but very few. The problem is that these are all very general purpose with loads of configuration options to handle every single edge case that every other person, developer, and team has, to the point where now when you look at a Helm chart and like the Bitnami repositories and so forth, is that every single line of YAML is wrapped in either a range or a conditional because it may or may not be provided by the default values or the custom values by the developer. And it's extremely painful to work with. That's not a real number of lines on a values.yaml, but I wouldn't be surprised now that we've heard about your 2.5 gig YAML file, so who knows. So can I, should I? Now, don't get me wrong, you should definitely be using Helm. It is still one of the best things that we've got if you want to go and deploy a third-party piece of software like Redis, Postgres, CockroachDB, and so forth. So those charts exist, use them, smart people work on them, but it may not be what you need longer term for your own software, for your own deployments. Now, composability. Now, we can do a little bit of this in Customize, but we do have to remember that this is nothing but copy and paste. So we don't actually have true composability. All we're doing is saying, take these bits of YAML, this little snippet, and put it in this bit of this file through a JSON patch, and then don't touch it anymore. We can't change it, we can't do anything else unless we apply another patch on the top of it. And if you've ever had to work with git merges and conflicts, you probably don't enjoy working with JSON patches anyway. So this is a 100% you can, but you definitely shouldn't. If you're looking at Customize as a way to provide composability, well, it's going to be very painful. Now, from a documented point of view, there really is nothing here whatsoever except for dropping down to the terminal and using kubectl explain. I'll caveat that with there is a VS Code extension for Kubernetes that probably most people in this room, if they're deploying to Kubernetes, have installed. But what you don't realize is this is not magically understanding the custom resources that are in your cluster. It's going out to your cluster. And if you can have your VS Code and your local machine speak to your production Kubernetes cluster, that's not exactly an ideal situation. Now, sure, you could point it to dev, and it will give you some type hinting and a decent LSP implementation where you can tab complete your way through resources. I just don't think that we're going the right route with this. And it's also horrendously slow. So it has to continually speak to the cluster, request the API versions, and then make that LSP available to you. So not ideal. So yes, you can, but you definitely shouldn't. Now, testable. Who knows what Rego is? Keep your hand up if you enjoy writing Rego. Oh, yeah, of course. This is what it looks like for anyone that's not familiar. It's just not that understandable unless you've been working with it for a long time. And even then, I come back to some of the Rego policies that I wrote a year ago, and I have no idea what the hell they're doing. So if you're not working on this day in and day out, you're going to lose that muscle memory, context, and then it's just going to be really painful coming back to it. So while I love what Open Policy Agent are doing, and the Rego language does provide some very great functionality and features, I just wish the language was more familiar to people coming from a C or Go background. And while it does share some things, if you can work out what this is doing, you're doing better than I can. So now, for anyone who keeps their finger on the pulse of Kubernetes policy, anyone know where I'm going? No fingers on pulses. Common expression language. This was added very recently to Kubernetes in 1.26. It allows us to write validated admission policies using a common expression language, which is a very small programming language from Google, where you can just say policies are expression, object spec replicas is less than or equal to 5. This is a fantastic addition to Kubernetes because it simplifies and makes it easier for developers, you, to get policies into your cluster and make sure that you're not doing anything too bad with your deployment and production artifacts. But it is very new, and I won't ask people to tell me if they're actually running Kubernetes 126 because it's never a good show of hands. Now, can I, should I? CEL, yeah, like there's a no-brainer. If you are on Kubernetes 126 or 127, start to bring that in whenever possible. If you want to invest in learning and working on your Rego knowledge, then I do encourage you to. But I'm here to show you that there are other tools that are familiar to you, that you will understand and support your own programming languages of choice. So what is missing from all of these things where we can do it currently, but we probably shouldn't? And that's the developer experience. Making sure that when you are sat down at your laptop or your computer or your monitor, that you enjoy, as much as you can at least, enjoy deploying to your Kubernetes cluster. So I always think of developer experience as just understand, how do we achieve what we want and do it by leveraging existing skills and hopefully enjoy it. And I'm going to do something totally pretentious and quote myself, but I love this quote. Where I just talk about, if we can be successful with our experience and intuition, rather than always having to go to kubectl explain, go to Stack Overflow, go to Google, research the documentation. Like, why can't we just take these 10, 20 years that we have as developers and apply all of that skills to what we're doing day in and day out? And that is what a strong and good developer experience has to be. So, if we want a strong developer experience, we want to deploy to Kubernetes, what are our options? Now, I'm going to be talking primarily about CDKates today, and we're going to be jumping into my terminal and some code to show you how CDKates work. So I won't say too much about it right now, but I do want to cover some of the other tools available in the landscape. The next one is Pulumi. We've already had a talk here on it today. Pulumi is a fantastic tool. But I probably wouldn't use it for deploying to Kubernetes. And I'm going to caveat this with two facts. One, I used to work for Pulumi, so I know Pulumi very, very well. Two, my entire time at Pulumi was trying to improve the developer experience of working with Kubernetes. The challenge is, Pulumi is based on the Terraform resource model. That means if you want to generate types and have Pulumi create custom resources in a cluster, you then need to write a provider that has a binary that is publicly available on the internet that can be distributed to your local machine, and then you have to install the SDK that describes those types and allows the resource creation to happen. So what we're going to see when I pick a random CRD from the internet to show you how it works with CDKates is that the Pulumi way just doesn't work. Now, I have sent them loads of feedback, and I hope that they change it, but right now it is not the best bet for Kubernetes. And Terraform, unfortunately, lies in the same boat. It used to be that they supported deployments, services, all the core APIs, but then, of course, none of us are deploying to Kubernetes with just the core APIs. So now they do Kubernetes manifest support where everything renders to a Kubernetes manifest, and that does get you so far, but again, we're not getting that developer experience of what is the spec? What can I put in here? Is it a config map reference? Is it a config map name? Like, what is it I'm working with? And we don't get that with Terraform. Also, just because I ran into it the other day when I was writing some actual Terraform Kubernetes, if your custom resource definition has a property called status, it automatically won't deploy it to the cluster because it feels that that is a protected term and it is not in a Kubernetes custom resource, and it does not work. And it's been an open issue for 3 years, and it pained me and hurts me all the way down to my core. Now, Q. Anyone heard of Q? Come on. Right, not get that many hands. That's okay. Q is a fantastic project, also out of Google, that wants to remove YAML and JSON from your lives. It has some very great features. Everything is a merge. It spits out arbitrary formats. It does recursive parsing of YAML and JSON into a structured Q value. It's very cool. Stefan Prodan, who's the maintainer of the Flux project, is working on Timoni, which allows you to take Kubernetes Q-based resources, have a GitOps workflow, and deploy them to your cluster. Now, it's super early, but it's very promising. They just shipped support for generating Q definitions, which gives you LSP support based on custom resource definition YAMLs from the OpenAPI spec. So very, very cool, and I'd love to be able to say that you can start playing with that now, but probably need to hold off a little bit more. And then there's Go. Again, 5 years ago, it was safe to say that every single Go or Kubernetes operator was probably written in Go. But that is not the case anymore. We're seeing much more Java, Rust, Zig, and other languages popping up as people want to explore and use the languages that are familiar to them. So it used to be, sure, we could always just import the type definitions from a Go package and deploy it, but that's getting less and less true. So it's not really a viable option any longer. Which means we've got CDKates, which is good, because that's what we're going to take a look at. So CDKates is a CDK implementation that allows you to deploy to Kubernetes. And it does this in multiple languages, which is provided by the JSII project, which allows you to have like a low-level description language, which I guess generates SDKs in programming languages of your choice. And it supports Go, JavaScript, TypeScript, Python, and Java. And they keep threatening to add more languages, and I keep upvoting the Rust issue, but it's not happened quite yet. Hopefully soon. Now, the benefits here are the same things that you've heard from every other session in this talk, right? We want to use our IDEs. We want to use VS Code. We want to use our extensions. We want language server protocols. We want to be able to click around and debug, and all of that is 100% possible. CDKates is also a CNCF project, so it has that governance. It's not by AWS. So it's safe to use and trust. It has constructs and charts, which are just terminology from the CDK project, which we'll see as we start to type some code. It does some dependency management, which is typically a difficult problem with Kubernetes because it's declarative and you just throw everything at it and let it reconcile eventually. The CRD support is unbelievable. Literally, I will show you just how good that is. And it actually integrates with Helm 2 and does this via Helm templating, so it still spits out YAML. We do lose some of the functionality like Helm hooks. And then they really tried to elevate the project with something called CDKates Plus, which provides new APIs for describing Kubernetes resources that we just haven't seen in the past. So what does it look like? Well, I could do it this way and show you loads of code on a boring slide, but we're not going to do it like this. And as I made this slide, I realized that we're now at a stage in the future where there's people that are going to get in this room and born after this movie even existed. So that was slightly terrifying too. So let's do some live coding. So this is a CDKates TypeScript. I guess it's a project where we have a chart. A chart just means we're going to print out some sort of YAML. If you need more control over your CDKates, you can have more and more charts and nested charts. These will all be rendered to their own YAML file. Depends on how you want to work with the YAML afterwards. We can maybe touch on that in the questions at the end. All we need to do now is start defining some resources. And then this is just a wee boilerplate at the bottom that just creates a new chart and synthesizes it. All CDKs do this, where it's Terraform CDK, AWS CDK, CDKates, or I'm sure I'm missing a CDK, there's probably another one. They all go through a synthesizing step where they spit out some artifact that you can then run. The Terraform CDK is actually really cool because you get a Terraform JSON and you can Terraform apply it. However, we just want Kubernetes YAML. So if we think back to that list of resources that we had for deploying to Kubernetes, we probably want a deployment first. Now, I hope I did an npm install beforehand, otherwise this will be a short demo. Import. Okay. So this is a just-in-time generated SDK for whatever version of Kubernetes I want. This is all handled through a cdkates.yaml. And all I've said here is import the Kubernetes API. If you want, you can then say that you want a specific version. But for right now, we'll just pull in Kubernetes and let it do its thing. It will pull the latest. This SDK generation happens because we can run CDKates command line, where we can ask it to import, which runs through all of the imports in that file, like so. So this is importing Kubernetes, 125. I'm not sure why that is. It's probably the version of CDKates that I've got, and that's the most recent that it's aware of. This means here, I can import a class called kubedeployment. Now, obviously, I know what a deployment looks like, but I'm going to pretend that I don't, and just say, well, let's have a new kube. Oh, I should have turned off Copilot, but you know, that's all right. Let's just call this Nginx because that's what everybody demos. And now we get our tab completion. So my LSP tells me, well, we need something called metadata and we need something called a spec, or at least they're optional types. So let's do the metadata and then see that we need to, oh, okay, we've got all these optionals, but we're going to provide our name. And it wasn't part of the demo, but the fact that Copilot is filling in some of this for me is providing to that developer experience, which is nice. We then need a spec, which doesn't need a promise. Spec, template, and I said I knew this stuff. Spec, template, spec, containers. Then we get a container, which needs an image. I don't even know if that version is real, but I'll trust Copilot maybe. And a name. So, this is now giving me error detection in real time. Now I'm missing the selector and the metadata on the pods, so we can work our way through that too, where we have to say, okay, we need a selector, which is going to be match labels, and we'll just say app Nginx, and then we'll need that down here too. Labels. And we now have a Kubernetes deployment. So from here, we can say CDKates synth, and that spits out our YAML file. So now we have a Kubernetes deployment with hopefully enough working stuff, although I'm not actually going to try and deploy it, so it doesn't really matter. And that works for all of the core resources. We can do kube service, secrets, config maps, network policies, and so forth. So that's pretty cool off the bat, but it does offer more. So let's assume that we actually have a whole bunch of different deployments in this file. We then get to start to refactor it. This is where using languages and tools that you're already familiar with becomes a huge advantage, because who knows how to refactor their own code? I mean, hopefully everybody. So let's just take this and say, well, let's provide a function, and I'm going to have this in the same file. Obviously, this is not the way we do it for a real production deployment, but we can just say, create a deployment, which needs a name and an image. And then we'll just drop in our kube deployment. Now, this is where one of the first weird things happens with CDKates, is that we have this scope or context or construct. We always need to provide a base level construct, because this behind the scenes, what CDKates is doing is adding them all to a big list, so it knows what to synthesize and what to render. And also it allows us to do some aspect-oriented programming on top of this. So if you really want to, I won't do the demo just now, but we could grab a scope, which would be our chart, and say loop over all of the resources that you're about to render, and do augmentation or enrichment of those resources with common labels, annotations, setcomp profiles, whatever you want. And these are composable and can be higher order functions that we ship on NPM or within a monorepository or file and so forth. So the flexibility and the power is pretty neat. So here we'll just say this is Nginx, and we're going to pass the context as this, and we'll just take that down here. And the scope is just a construct, which is a primitive of any CDK, like so. So now if we run a synth, we should get an error. Value is never read. Oh yeah, I should probably use it. That's another thing. It ships with a very opinionated TS config, and if you assign things or don't use values, it will complain and tell you that that is a terrible idea. So now we need to clean up our code, where this should be name, and we can use short syntax here and just say that's our name. We can do the same here, and here, and the image, like so. So you can see already we're starting to tidy up this definition of what our deployment looks like. We can take this a little bit further, and we could assign our labels to a value like this, where we say this is labels. Oops, don't do that. Like so. So we're just continuing to evolve. Our deployments to Kubernetes now becomes a software project, which brings us all the benefits of existing knowledge and being successful with our experience and intuition. So we can take a look at our YAML again. Oh, wrong one. There's a dist file. Just pop it open here. And this is not really going to change that much because we're just refactoring. Which then brings in another benefit. We can now do snapshot-based testing where we say, has this file changed in a way that we expect or don't expect, and bring this into our pipeline too. And that's something that CDKates does set up by default for you. So if you open the main test.ts, you can see here that it does match against the snapshot, and it's always creating snapshots when you run up here. Or at least you can configure it to do so. So that's pretty cool too. So hopefully it kind of shows you a few things. We refactor to a function, but we could put this into its own class, which allows us to do something even more cool, where we can say, well, let's have a raw code deployment which extends a kube deployment, which needs a constructor, which is going to have our scope and our ID, which is just going to call super ID, like so. Now, well, that would actually need an interface, wouldn't it, right? So we can say config, and these names are going to be terrible just because I'm doing this very quickly. And we could take our config here. So everything is typed. We get successful messages. Things are happy. I'm going to cheat and just use our create deployment function and pass in the things that we need. But now we could say, well, what if we want to change or enrich this deployment? Let's assume, and I'm not going to type this again because I'm getting a little bit short on time. We could have create service, but we could also just say, well, why don't we expose with a service? And then we get a Fluent API. We could then have our deployment where we say expose as service. Now, I'm not actually going to make this code work because CDKates already provides all of these examples for you in a project called CDKates Examples. So if we pop open one of the TypeScript ones, we can pop down to this web cache and pop open this. We can see here that we have something that extends a chart, so they're making sure that the blast radius of this is a single YAML file. They're using the K+ library, which is where things get really slick from a developer experience, where now we can start to say that we need labels and annotations, and it does this in an interesting API. We define our stateful set. Only now we can say, from a scheduling point of view, we want to attract it to a particular set of nodes. From the deployment perspective, we can then say that we need environment variables, and they come from values. We can also do from config reference, from secret reference, and so forth. And then there's the expose via service function here. And this is all available to you out the box. In order to use this, all you do is go to your package.json and say that you want CDKates plus, and then the Kubernetes version that you want. If it was 27, you could just do that. Now this becomes immediately available to you, and you can do stuff. Now the last part of the demo is custom resource definitions. Everything I've shown you here, you could do with Pulumi, but I said the challenge with Pulumi is the Terraform resource model having to ship and make a binary available to everyone in order for them to generate an SDK for the custom resources. But with CDKates, that's not true. So let's go to Cert Manager on GitHub. The reason I'm using Cert Manager is they published their custom resource definitions on our release artifact, which is handy for the demo, where we can copy this link. From this link, if I can find my terminal, and I don't need to save any of that crappy code, we can open our cdkates.yaml, and all we need to do is paste that in. Now, when we run CDKates import, we get Kubernetes and all the Cert Manager resources, which means I can now come back to our main.ts, import from imports Cert Manager, where I can say that I need a new issuer. Now, you don't need to know what this custom resource definition is. Why? Because we have a good developer experience. but a terrible typer. So this, production, and just tab my way through it. What do I need? Okay, I need a spec, self-signed, like so. Now, Copilot already knows how to do this. I'm not sure how. It just seems to be magic, but you know, let it. And too many braces. And now we have an issuer. So let's just run a synth one more time. I don't know why that's paused. Might be my internet, but I don't think it's important. Oop. Yeah, that's that TS config where I've generated stuff that I'm not using. So let's just delete this. And if it fails again, I'm going to delete the TS config. Good. So now if we come into our dist, we have our Kubernetes deployment and our cert manager custom resource with pretty painless, right? Easier to find, easier to do that than find my slides. Okay, so with this new power and functionality of CDKates and a great developer experience, you can now start to build internal pattern libraries. You can decide as an organization what a deployment looks like, what the artifacts that are needed to do, encapsulate them in a class or a function, whatever you want, distribute them on PyPy, GitHub, NPM, and make them free and available for everyone else to use. You can do policy and tests. So policies, we can use the aspect-oriented stuff to say loop over the resources and check that there's always a security context where we don't allow people to run as root. Make sure they're dropping capnet admin if they don't need it, and so forth. And then the snapshot-based testing works, but if you're familiar with Jest or PyTest or even GoTest, the tests are just against a structure that you can build yourself. You can say, we expect this to look like this, and it works. What's really nice, and I didn't show it, but you know, if there are no questions, I will, we can hook into existing tools. So we can do Helm deploys. We can pull in customize with the include directive, and point it to a remote Git repository. We can even integrate this with Terraform CDK. Our applications aren't that simple anymore. Sometimes we need to provision cloud resources like DNS, S3 buckets, DynamoDBs, whatever. So why not have a Terraform CDK that does all that, and it can actually wrap and consume your CDKates construct and do it all in one smooth motion with GitOps-based operators too. So there's a lot of power, a lot of flexibility, and I hope that it makes your lives a little bit easier. Thank you so much for your time.
So this is super cool and solves a lot of the problems I've had with Helm in particular for a long time. Do you know if there's a good way to wrap CDKs with Helm? Because I can see for like a lot of operations teams, right, that's going to be the problem. It's like, I only know how to do Helm things. You can't give me a new thing to do, you know?
So you can't wrap CDKates with Helm, but you can still consume your Helm charts. So from here, we can just say imports, Kates, and what we want is, what's it called? Yeah, I think it's Helm. You know what? It's actually part of CDKates. So yeah, there we go. So we can just say Helm and say we want to deploy a new Helm chart, which still needs our scope. Say it was going to be cert manager, and then we can just provide the repository. We can provide the chart name. We can provide the version, and then we've got this values where we can just drop in whatever we need. So you can describe all of the Helm chart deployments in CDKates. It will actually consume and fetch the chart, template it out for you, and it all gets rendered into the YAML directory. So you don't have to throw away Helm. You're not losing Helm. Helm still has its place. It's still got its purpose, even if it's not got the developer experience that we typically want. What I would love to see that doesn't work yet is we're now in a position where through the Artifact Hub, all of these Helm charts have type definitions on the values. And I'd love to see them pulled into this kind of situation where we can then get our LSP and autocomplete in here too. Don't know if anyone's working on that, but that would be awesome.
Isn't actually that many people fill out type definitions and Helm values? I'd be impressed to see that.
Yeah, a lot of the more popular charts now have this. I mean, the syntax is terrible. It's embedded in the YAML, but you know, it does help. It does provide a better developer experience. But we can do better.
I was wondering if anyone solved using this and something like Java, a case where you have multiple microservices that depend on a Postgres database, but instead of having, because right now we use a complicated Helm syntax to determine whether or not one has already been established, and we will build one if it doesn't already exist. But is there like a singleton pattern where it's like, oh, you've just developed a Postgres database, and then anyone else that like has a CDI style like dependency upon that can then either bring it in, or if it doesn't already exist, it gets created at that instance. Does that make sense?
Yeah, it does make sense. So if you were to encapsulate this in Terraform CDK, you would be able to have multiple stacks where there's like a platform team that handle the Postgres operator or the Postgres instance itself. And then that could be a stack dependency further down from the CDKates point of view, where it would actually interact with that directly. But even without wrapping it in Terraform CDK, just having a platform team that provides all of these building blocks, and then your teams can just pick them up and use them as intents, is the better foot forward, rather than trying to bake it in with conditionals and weird Helm syntaxes. Yeah, the mic's just coming.
So the expectation is you have a platform team or some team is going out and building your charts and your custom constructs, and then the developer teams are actually just writing code against those, so they're importing those in some ways.
Yeah, I mean, maybe something we can talk about for the next hour if nobody's in a rush, right? But Kubernetes is not a platform. We don't just give people a cluster and say, carte blanche, have fun, right? We need to put guardrails in places. We need to, especially with microservices and multiple teams and loads of things happening, you need to make it as easy as possible for people to get that code deployed into production. So typically what we're seeing is platform engineering teams that have all the infrastructure as code, spin up the clusters, bootstrap it with enough GitOps to get the operators in place, and set up the GitOps pipeline so that then you as a developer team just come along and provide an artifact and an OCI registry that then gets consumed and deployed. So once you get to that stage, the developers are then coming to this bit where they're starting to write their kube deployments, their services, and so forth. But you're going to notice patterns, right? It's now a software project. So say, oh, we're all writing a deployment, we're all writing a service, let's wrap it in an API and just make it easier. And then what more developer teams need is opinionated ways to deploy, not just giving the developers the ability to write an arbitrary YAML and off they go. You know, policy is important, testing is important, security is important. So getting that into their hands and give them an SDK like this, where they don't have to worry about generating seccomp profiles in Kubernetes for the kubelet to pick up. It's just done for them.